How's everybody doing out there? Welcome to another wonderful Thursday afternoon of learning about AP Calculus to prepare you, the student, for the AP Calculus exam, which is in how many days? 42 days! What famous athlete was number 42? Call on in if you know what famous athlete was number 42. I understand we already have a caller. Molina Jaguar.
Hello.
Hello. Who's this?
Rocio.
Rocio?
Mm-hmm.
How you doing, Rocio?
I'm fine.
What did you do today in class?
We didn't have class yesterday.
What did you do yesterday in class?
Finding the area, the volume.
Finding the volume?
Yeah, between.
How do you feel about that?
It's kind of interesting.
Kind of interesting. I think so too. Let's give you a problem about finding the volume, okay?
Okay.
Let R be the region enclosed by y equals x squared, x equals 2, and the y-axis.
Okay.
Before we find the volume, if it's rotated by R, find the area of R. How would you find the area of R?
Draw it.
Draw it?
Yeah.
Okay.
X-axis. Y.
So we're talking about x equals squared, x equals 2, and the y-axis. I think it's,
The little triangle.
So
Not triangle, but that little thing right there.
I think this is meant to be the x-axis to be accurate. So I think we're talking about this region here.
What?
Okay. I think we're talking about the x-axis instead of y-axis to make it a little bit easier. So how would you find the area of this region right here? If this is y equals x squared right here, this is x equals 2. What would you do?
Okay. B equals?
No, I want the area first.
Oh, the area?
Yeah.
Integrating from 0 to 2
0 to 2 of what?
of x squared.
Right, that's pretty easy, right?
Yeah.
And it's x cubed over 3 from 0 to 2, so the answer is 8/3. That's the area. Well, how would you find the volume of this region if this region is rotated about the x-axis?
Okay, it's V equals
Volume equals,
pi. Integrating from 0 to 2 of quantity x squared dx.
right, because what you do is you're adding up a billion little disks, right? And the area of each disk is pi r squared. And integrating adds them all up from 0 to 2, and the radius of each one is what the height is, which is x squared. Okay, so this is easy enough, right?
Mm-hmm.
This was too easy for you, Rocio.
That's all right.
Hey, did you guys learn washers yet?
Yeah.
All right, so you guys, all right, so we're way past that. So the answer is going to be 32 pi over 5, right?
Mm-hmm.
That's a fine job, Rocio!
Thank you.
Hey, call it again, all right?
Okay. We need to get the little bitty ones to Casey.
We need to get the little bitty ones?
Hi, Mr. Fleischer.
What little bitty ones do you need to get?
Flowers from little bitty stores to donate flowers. Little bitty flower shops to donate to NHS so we can plant flowers and beautify our school.
To beautify your school.
That's right. No, our school.
You're doing a really good job of it so far.
Hey, Annalisa, I'm gonna have to get with you. I have a phone number to give you of someone. Actually, I probably should give it to Rachel, since Rachel will be the only one brave enough to call him. Hey, Annalisa?
Hold on. Wait, hold on.
Annalisa?
We haven't done volume.
You haven't done volume?
Nope.
Okay.
And Casey wants to know if you can get different pizza for tutorial.
No.
No.
But it wasn't just me, it was all President's Council.
Okay. Hey.
You guys be quiet.
Hey, I don't want you to find the volume. I just want you to find the area of this region. Y equals e to the x, y equals x, and x equals 2, and x equals 0. Find the area of that region.
Uh-huh. Okay, hold on. What?
Okay.
equals e to the x. Can you guys please be quiet?
April 20th.
Mr. Fleischer? Trying to do math here.
Okay, well, April 20th, that's a math, isn't
Okay. Okay, y equals x.
it? When you want to find the area, what's the first word that comes to your mind, Annalisa?
Area?
When you want to find the area in calculus, what do you want to do?
Integrate?
Integrate! So you want that beautiful integral symbol,
That little SE thing.
little SE thing.
Okay. I was drawing my picture.
So e to the x looks like this, y to the x looks like this. So we're talking about this region right here.
Okay.
So what are we going to do?
I don't understand. Okay, hold on. I have to draw this, Mr. Fleischer. You're going too fast.
Okay.
Okay, 2 there. So we want the area under the curve?
Well, when you have two
Or do
curves,
we
you want
are we doing the area in between the curves?
right area in between the curves. You want this is the top region, this is the right region, right boundary, left boundary, bottom boundary.
Okay.
BB.
What was that?
BB, bottom boundary.
We haven't done
Okay.
drawing yet.
He's just having me find the area. Okay, so where am I?
So which curve's on top? What's on top? E to the x is on top.
Easy. Okay, good. That's what I was gonna say.
Okay, so it's just going to be the integral of e to the x minus x. What's the integral of e to the x?
E to the x,
What's the integral of x?
x squared over 2.
Excellent. Okay, I want you to give me the answer from here. What's the answer after this?
Like, oh, you mean like minus the bottom?
Yeah. Tell me, what's the final answer?
Well, you have to plug in the bound.
Plug it in.
E to the 2 minus, no, is that minus? Yeah. 2 squared over 2,
Which is 4 over 2, which is 2. Okay, is that the answer?
no,
Okay.
minus e to the 0,
What's e to the 0?
1.
Okay. So it's negative 2 minus 1, so the final answer is e squared minus 3.
Yep,
Isn't that exciting?
very.
Annalisa? Got a phone number for Rachel to call, all right?
Rachel's not here.
Well, you'll have to give it to her because you're too chicken. All right, who's next? Butters!
Hey, how you doing?
Hey, how are you doing?
Good.
How are you doing, Butters? What's going on?
Right, nothing.
Nothing. You ready?
We're eating right now.
What are you eating?
Salsa verde and some cheese stuff.
Salsa verde?
And some cheese stuff. It's really good.
Yeah, that sounds pretty good. Salsa verde. You know what that means?
No clue.
Green sauce.
Okay, I'm not gonna eat it anymore.
Okay. Anyway, here you go. Either that or tooth sauce. I don't know. One of the two.
Oh, did you save that for me? Oh,
I did.
how sweet.
Find the volume when this is rotated about the line x equals 3. So we're talking about this region right here.
Just draw it again.
Right here, this is 2. I want this rotated about x equals
Okay.
3.
First of all, it's all Y language.
It's what?
Y stuff, it's all with Y.
It's all y. Good, good.
Okay, I think we're gonna have 2 integrals because of the weird radiuses.
The weird radii.
Whatever.
Either that or,
Either one.
or radiu.
Radiu.
Radi me.
Okay. Let's do the x equals natural log of y is the first function over there.
Oh, so you want to change this, huh?
Of course.
Because you're sort of rotating about like the y-axis, right?
So I have to have everything in y, right?
Right. So this is x equals natural log of y. All right. Okay. Good. Good.
X
Good.
equals y is the other one.
And the other one's x equals y. Okay. What do we do now?
Okay. When x is 2, what is y in the first function? Plug in e to the e squared. How much is that? 4 point something, right? I'm trying to find the point.
You're trying to find the point?
Yes.
Okay.
The first point over there is 2 and then 2 e squared, which is something. Hold on, can you turn it down?
So this would be e squared.
Yeah, e squared.
E squared.
And the other one would be 2, right?
Well, I think it's just 1 because it's e to...
No, not that one. I mean the other point. 2, 2.
This point right here?
Yeah.
Yeah, it's certainly not to scale, is this thing?
Yeah, it's so not to
So
scale.
here, I'll try to draw a little better for you here.
Yeah, it's easier to see if you draw it nicely.
Okay, I'm going to try to draw it nicely for you. So this is 1, this is 2,
That's
this is e squared, right? Well, it is a hard problem, isn't it?
Oh, yeah, it's okay
I
there.
don't think I meant it to be this hard, but...
It's fine.
Okay, you can handle it?
Yeah.
Because you're badass. Go ahead.
Okay. Okay, let's do this with 2 different integrals, because...
Yeah, I think it has to be 2 different
Let's
angles.
have an integral from 0 to 2.
From 0 to 2.
Yeah, I
okay.
get that
Well,
one.
let's try to show why it's 2 different integrals, because you have 2 different, when you do this, when you have this little washer, you have, in each case, the radii is this, the outside radii is that curve, and the inside radii is that curve, right?
Yes.
And then from here to here, you have different radii. So this is really, really hard to follow, and most of the teachers will have to be able to explain this. This is probably harder than anything you'd have on the AP exam. So you want to have something from 0 to 2. What's the? We're going to try to fly through this because it's so hard.
Okay,
What's the radius
put
here?
the pi out front first. Put the
Pi.
pi there.
And what's the outside radius going to be?
The outside radius, I think, would be 3 minus the function. Is that
Right,
0.3?
it's 3 minus natural log of y squared.
Squared minus, the other one would be
3 minus y
the other
squared,
function.
okay?
Squared.
And that would be sort of the bottom region, and then you would
Right.
add to that, boy, Butters, this is amazing.
Then you go from 2
to the
e squared, and then you have
3 minus what?
3 minus, what is that line? X
Natural,
equals 2?
well, the outside would be natural
Yeah,
log of y,
natural log of y,
and then the other one would just be 3 minus 2,
3 minus 2, which is 1.
or 1 run, and that's it. Butters,
Right.
that is impressive, Butters. Hey, how come you didn't try the question of the week last week? You know that Francisco Hernandez from Skyline and Josh Newton were the only ones who got the answers right, and it wasn't even that tough of a problem.
I didn't have time to look at it.
Butters, no excuse, Butters, no excuse.
Well, last time I got it right, I didn't get any money, so...
Well, hey, sometimes you just gotta, roll the dice there, all right?
Nah, it's okay. I'll
Hey.
do the next one.
Great job on that problem, great job.
Okay, thanks.
James?
Yep.
James Nagler?
No.
James Miller, I'm just kidding.
Yeah.
Jimmy Miller,
Yeah.
how you doing?
Pretty good. How you doing?
Pretty good. Have you guys done volume yet?
Yeah, we done a day of it. Yeah.
A day of it?
Yeah.
Well, I think you're ready.
All right.
Who's, does Mr. Irby ever tell you jokes in class?
Oh, lots of them. Yeah, they're not very funny though.
They are. I don't think I have your picture, do I?
No.
Okay. Hey, so if this thing is rotated, if this region is rotated about the y-axis, first ask Mr. Irby if you've done these washers yet. Have you done washers yet?
Yeah, we've done washers.
So what are you going to do if you want the volume of this solid? How would you figure it out? First of all, does it have a hole or no hole?
Yeah, it does have a hole.
If it has a hole, what you're going to do is always set it up like this. If it has no hole, you'll set it up like this. But if there's a hole, you can have an outside radius and an inside radius. So tell me. First of all, what am I going to integrate from what to what?
0 to 2. No, around the y-axis. Okay. Yeah, from 0 to 2.
0 to 2 or 0 to 4?
Oh, okay. Now that you put a 4 up there, 0 to 4.
Are you sure?
Yeah.
Why?
Because you are integrating from the top to the, or from...
That's right. But if you're going across the y-axis or any vertical line, you're going to use y points. So remember that if it's rotated about the y-axis or any other vertical line, you're always going to use y points, because when you draw the washers, you're going to add them all up from here all the way up to 4.
Okay.
But the key to remember is if it's y-axis, you're going to use y points.
All right.
Or even if it's a vertical line like x equals 3, you're going to use y points. So it's from 0 to 4. What's the outside radius in this picture?
4.
What's the radius?
2.
Right, so it's 2 squared, and what's the inside radius?
The inside radius being like like inside like the little hole.
Yeah, right, exactly. What would that be in this picture?
The square root of y.
It's going to be whatever x is, which is the square root of y. Excellent. Did you do that all by yourself?
Oh yeah.
Hey, Jenny, we're just going to set it up. We're not going to do it. Professor Miller?
Huh?
That was a fine job, Jimmy Miller. Fine job.
Thank you.
Tell your class to give you a hand there.
Okay.
Okay, all right. Call it again.
All right.
Evelyn,
Yes.
are you nervous?
Yes, I am.
Why are you nervous?
Because this is my first time calling.
I know it is. Why is it your first time calling?
Because I get nervous.
Okay, I'll tell you what, we'll give you, because you're so nervous, don't be nervous, but I hear this is a national audience today. And I've been using that joke for like 10 years, and it's like, it's never been funny once, Evelyn. It's very sad. Not once. Okay, let's do a derivative problem for you. Aww. Okay, if f of x is equal to x minus 1 over x plus 1, for all x not equal negative 1, then what's f prime of 1, Evelyn? If this is f of x, what's f prime of x equal to?
It's, okay, I know this.
Okay, take your time.
It's the denominator times the derivative of the numerator.
What's the derivative of the numerator?
Negative 1. 1.
1, okay. So times 1.
Minus the numerator, which is x minus 1, times the derivative of the denominator is 1,
Okay.
over the denominator squared.
Okay, good, Evelyn. Now, how do you simplify the numerator?
Distribute the negative to the second one.
Okay, what do you get?
Negative x plus 1.
Okay, so we got negative x, so we got, it becomes x plus 1 minus x plus 1 all over x minus 1 squared. That's what f prime is. And what is, that was it simplified to now?
2.
So it's 2 over x plus 1 squared. So what's the answer to our question? What's f prime of 1 equal to?
1/2.
Right, it's 2 over 4, which is 1/2, right?
Yes.
Okay, Evelyn, it's good, Evelyn. Evelyn,
Yes.
say Jack. No, say Jack. She hung up. Christy Knapp,
Yes.
you know, I think you're the one who started all this calculus dating service, weren't you?
Me? No, it was Emily.
Oh, it was Emily. Okay.
Yeah.
All right. Hey, was that Emily in the background?
Yep.
Hey, Christy,
Uh-huh.
we're gonna do some more derivatives here.
Okay.
Little implicit differentiation.
All right.
So let's try this. Negative 8x squared plus 5xy plus y cubed is negative 149. Negative 149. Find dy dx. Dy dx.
Okay. It'll be negative 16x plus 5x times dy over dx
Right?
plus y times 5. Or
Okay.
5y.
That's good. Excellent. Excellent.
We move the paper over a little bit. All right, thank you. Plus 3y dy over dx. Whoa.
Plus
I mean
what?
3y squared
Plus 3y squared
dy over dx.
Equals.
0.
Okay, now what do we do?
Put the dy over dx like on one side. So take the negative 16x to the right. And the 5y.
It's like that?
Uh-huh.
Okay, now what do we do?
Factor out the dy dx.
Okay, so you get dy dx is equal to
5x plus 3y.
16x minus 5y all over 5x plus 3y squared, right?
Yeah.
Okay, try to answer this question now. Question number 2. Write an equation for the line tangent to the curve at the point 4, negative 1.
y minus, or y plus 1
y plus 1,
equals that whole little equation up there.
the whole what?
Oh, okay, hold on. Oh, we gotta work out that. Put the 4 and the negative 1 and the,
Right, you put 4 negative, if 16 times 4 is 64, minus a negative 5 is 69, all over 20 plus 3, you get 69 over 23. So that equals 3. So the slope is 3, right? You plug these into dy dx, and then you get x minus 4. Hey, Chrissy, that's a fine job.
thank you.
Do you know that was on the 1995 AP exam, free response?
Really?
Yep, it sure was.
Alright, thank you.
No, thank you. Thank you. Is this Ben Wright?
Oh yeah.
Oh, yeah. How
Oh
you doing?
yeah.
Oh, yeah. Oh, yeah. Hey, Ben,
Yes.
we are going to give you a fun problem
All right.
because you've been asking for fun problems.
Have I?
Yes, you have. All right, here you go, Ben.
Okay.
You're humming.
I am. Okay. Now let's get started here. Let me see what this looks like. Okay, we're finding the area first.
Well, I'll tell you what we're going to do. Well, what we'll do is I'll help you out here. This is cosine x, and this is sine of x. So we're talking about this region right here.
Okay, are we going to rotate it around? We're going to rotate around the x-axis,
We're going to rotate it about the x-axis, so it'll look something like this.
and it's going to make some washers.
It is going to make some washers. Now, let me ask you a question here, Mr. Wright.
Yes.
If we're rotating about the x-axis, are we going to use the x points or the y points?
We're going to use the x points.
We're going to use the x points. Now, where is the point of intersection between cosine and sine?
It's probably going to be something I should know, right?
Well, yeah, probably.
Give me. Huh?
Who is your precalculus teacher?
My pre-calculus teacher, Mr. Morales.
Well, Mr. Morales is no longer there, so we can't ask him. Cosine is equal to sine. See if anybody in the class knows. When does cosine equal sine?
When does cosine equal sine, guys?
I'm just getting pi over 2s and things like that.
How about pi over 4?
Pi over 4.
Because what's the sine of pi over 4?
The sine of pi over 4 is wow. That's 45 degrees. So
Sine of 45 degrees
yeah,
is what?
is the square root of 3 over 2. No. It's just
Hey,
hold on a second. We're having help. This is my weak point, see?
have you seen this before, Ben?
Yes, you've drawn this before me before.
I've drawn this for you before?
Yes.
I have? I don't remember. 0, 30, 45, 60, 90.
Oh, well,
If you want to go to the sine of 45 is square root of 2 all over 2. Cosine of 45 is square root of 2 all over 2. You know what? Sine of 60 is square root of 3 over 2. Cosine of 60 is square root of 1 over 2. Have you seen this before?
yes.
So what's the sine of 45 degrees or pi over 4?
That's the square root of 2 over 2.
What's the cosine of 45 degrees?
The square root of 2 over 2.
So that is why that's when the sine is equal to cosine. Hey, Ben,
Yes.
I want you to draw this, and I want you to put it on a piece of paper. I want you to put it next to your pillow, okay?
Next to my pillow.
Next to your pillow. I want you to sleep with this. So there should be like drool stains on this. So you should know this.
But
okay?
then I might smear the beautiful numbers.
Well, not if you use smear-proof ink. Anyway, so we got this. We're going to rotate about the x-axis. We're going from 0 to pi over 4. And so what is the outside radius? I mean, what do we do now?
It's going to be the same thing you did before with the big R squared, little r squared, all times pi.
Right. And what's big R squared equal?
That's going to equal cosine.
So it's cosine squared. And
yeah.
what's little r equal to?
Going to be sine squared.
Excellent. Excellent. Okay. And now I'm afraid to ask this, but do you know what this trig identity is?
No.
Okay. Well, you know, and then
Give me something else to sleep with.
okay. Well, I think that this little chart is safe enough. Well, from here you could do this on the calculator, and Ben, next week's assignment is for you to memorize what this trig identity is. Okay.
Okay.
All right. And so you tell me next week what cosine squared minus sine squared is. All right.
You bet.
All right.
Oh, well, thanks.
I didn't do it. Talk to the guy that you called. Talk to Rosie, okay? Hey, Ben, have a good one. Call in again, all right?
Take it easy.
Yeah.
Julie!
Hi.
No, hi to you.
Hi to you.
Hi to you.
Okay.
What do you do? That's enough?
What?
You've had enough?
Uh-huh. I quit. You win.
Well, thank you.
You're welcome.
I like to win.
Okay. I win.
So who's is Matt there today?
No, I don't. No, not yet. He's coming, I think.
Okay, all right.
He's running late. Can you believe that? The calculus show.
You know, Julie, I don't know. Julie, what's your last name?
Thane.
Oh, Julie Thane, the senior class president.
Yeah, that's me.
I have a picture of Antoine. Do you want to see who you beat out for a class president?
All right. As if I don't know who he is.
Hey!
Yay for Antoine.
Who's he hugging?
I don't know. I think she's a freshman. Boo.
She's a freshman?
Yeah.
So Antoine's in. Okay, all right. Anyway, so how do you do this problem here? Let R be the region closed by y equals x squared, x equals 2 in the y-axis. Find the volume hour when it's rotated about y equals 4.
Can we draw it first?
Yes, we can.
Awesome.
Awesome, baby. First of all, if we are, the curve looks like this. If we're rotating about the line y equals 4, Julie Thane,
It's going to be x.
is the integral going to be from 0 to 2 or 0 to 4? Which one?
0 to 2.
Because we're rotating about a horizontal line, which is like x-axis, right? So, therefore, what do?
You integrate.
Find a point. Tell him it's 2,4.
I don't know. Well, that right there is going to be 2,4,
I
a
got
point.
2 and 4 there. Who said that? Who's
B's behind me, but
Who
I
is?
scooted away because she's talking to my aunt. I couldn't hear.
I know, it's really distracting.
Butters.
I know, Butters. Tell Butters you can handle this your own.
Oh, I can handle it, Butters. Okay, anyways. So we're going to integrate from 0 to 2. Put pi out front. And then, you're going to take... Wait, it's going to be a whole because we're doing around the
It sure is
x-axis.
gonna be a whole, right?
Big R squared minus little r squared.
Okay, what's big R? Hey, tell Butters to stop. Butters.
Butters, no.
Spread.
So it's going to be... Okay, she's what? She said all. So you take 4 squared,
Okay, very good.
and then you're going to subtract x squared.
Yeah, this is the outside radius is right here, and the inside radius is here. Now, what is this inside radius?
4. I mean x. It's,
Butters!
it's and then x squared.
It's 4 minus x squared.
x squared.
Because you know why? It's like this line, it varies. The inside radius varies. See,
So you're
it's
taking the
long-
whole thing minusing that little
Right,
part.
so it's all of this, which is 4, minus this, which is x squared.
Okay.
You see that?
Mm-hmm.
And then you would square that, and then there'd be happiness.
B says you're wrong,
Who says I'm wrong?
Butters.
Butters says I'm wrong?
I think she's confused. Hold on.
He's wrong.
She says you're wrong.
Is she sure that I'm wrong?
Yes, I am.
Okay, put her on the line.
Hold
then.
on.
The first radius that you have to do is 4 squared, and then minus 4 minus x squared squared.
That's what I have.
No, you can't even see that.
Well, that's what I have. You see
Write it
that?
out nicely so we can see it.
Butters.
Okay.
Butters, it takes a really proud person to admit, a really strong person to admit when you're wrong. It's okay. Okay, Butters.
You just don't write nicely. If you wrote it nicely, I would say
now,
you're right.
The honesty is a good thing. I have a horrible handwriting, and I agree with you. But Butters, say that Mr. Fleischer, you were right. I was wrong in thinking...
Okay, Mr. Fleischer, you were right because I didn't see it.
Okay. Excuses. Butters, fine job. Let Julie do it herself next time, okay?
Okay.
Okay, bye.
Bye.
Francisco Hernandez, $10 winner! Francisco?
Yes?
You win the $10 for the, you gotta get away from the TV though.
Yeah.
Want to show everybody the $10 winner for the question of the week? Francisco Hernandez. You will get it at the April 7th prep session. There he is! Francisco.
Yes.
I like how you did it where, by the way, always, answer for calculus is always going to be in radians. Always keep.
Oh, okay.
Are you taking physics also?
Yeah.
You have Mr. Castro?
Yeah.
Oh, I didn't know that. That's awesome. The physics they use degrees, but the AP calculus exam is before the physics exam. Make sure everybody who has that, your calculator is in radians for calculus and degrees in physics. Okay? Because it'll really mess you up if it's in degrees. But that was a great job. Hey, have you done volumes yet?
Yeah.
Okay, here you go. Let's try this. Same thing, sine of x and cosine x. So we've seen this before. We had this before, and this is pi over 4. We want this region, actually no rotation. We want this where this is the base of a solid whose cross-section perpendicular to the x-axis are squares, so find the volume of the solid.
Okay. The area of a square is the side square?
It's a side square, right?
Yeah.
So, help me out.
The integral from 0 to pi over 4 times
These are popping out right at you.
Sine of x minus cosine x.
Which is on top?
Sine of x.
No, this is actually cosine x,
Oh, okay.
right? So it's cosine x minus sine x, quantity squared. Hey, I'm going to show you something in a second, but if you had to simplify this, this would be cosine squared minus 2 cosine x sine x plus sine squared x. So this actually simplifies to something. Do you know what? First of all, do you know what 2 cosine x sine x simplifies to? Remember that identity?
Sine of 2.
Very good. Sine of 2x. And cosine squared plus sine, cosine squared plus sine squared is 1. So it's 1 plus sine of 2x. And that is a lot easier to integrate. It's a lot easier to integrate than that, right? So you could have done that. Hey, I'm going to ask you something. That's excellent. But if it wasn't squares, if it was semicircles, this is what I want you to do for next week. I want you to give me a formula. For squares, it's just let's say it's y1 minus y2. I want you to give me a formula if they were semicircles for equilateral triangles and if they were isosceles right triangles. It's the same formula every time if you use these. So for next week, I want you to tell me what these formulas are.
All right.
Okay? In other words, if these were semicircles, it's automatic. It's automatic what the answer is. You don't have to go through the geometry each time. But you will have to go through the geometry if this was isosceles right triangles and the region is the hypotenuse. Okay?
Yeah.
So go through those next week. Give me the formulas each time.
Okay.
In other words, what I'm asking for, just to let you know, if you have 2 curves, whatever they are, if this base is squares, then the formula is just y1 minus y2. This will be, the top curve we'll call y1, the bottom curve we'll call y2. That's for squares. I want the formula, if this is the diameter of a semicircle, I want the formula if it's a side of equilateral triangle, I want the formula if it's a hypotenuse of isosceles right triangle. You know what I'm asking?
Yeah.
All right, that's great. If you can do all that, it'll be a piece of cake when you get on the AP exam. Hey, great job, Francisco.
Thanks.
You get that $10 April 7th when you come to the prep session.
Okay.
Who's next? Rodrigo! Rodrigo!
Hi.
Hi. How are you? Fine. And don't whisper those, don't whisper soft, sweet nothings in my ear. Hey, Rodrigo, got a great problem for you. And I know that Ms. Brzezinski teaches us a little bit differently, and it's really cool the way she teaches it. So you're going to have to show everybody how she teaches it. E to the x, y equals x, and x equals 2. Rotate about the line y equals -3.
Okay, move the line up.
Move the line up. That's what you guys do, right? You move the line up.
Yeah, exactly.
So how do you move the line up? Oops, I didn't mean that. Rodrigo, how do I move the line up?
Oh, y equals 0. So you can rotate in the x-axis.
Okay, so what do I do? Tell me what the new functions would be.
E to the x plus 3.
Right. See what they do. If it instead, they like to always rotate about the x or y axis, so they just create new functions. They'll shift these guys up 3. They'll shift this whole thing up 3. In effect, it'll be the exact same region. So what they'll have, it'll look like this, where this is 3 and this is 4, and now you're rotating about the x-axis. And this new function is e to the x plus 3, and this bottom function is just x plus 3, right?
Yep.
Okay, so therefore now from there, you know that this is, that's 2. So what are we going to do? So we're rotating this region about the x-axis.
Put the plus 3 down on e to the x.
What do I write?
It's e to the x plus 3.
Okay, e to the x plus 3.
Volume equals pi, integrating from 0 to 2. All squared. Minus x squared plus 3.
Okay, good job. And that's all you do, and then times dx. Okay? So you could do it like that. Otherwise, you're going to get the same answer. It's just that what you guys do is you rename the function, and that's a great way to do it. All right, Rodrigo?
Yeah.
Rodrigo? Say Jaguar. Okay, never mind. All right. Hello?
Hey,
Josh Newton?
no.
Joshua, what school?
Woodrow,
Joshua from Woodrow.
Cupid.
This is Josh Chupik?
Yes.
How you doing?
Pretty good.
Pretty good. How's calculus going?
Not good,
Why not?
because it isn't.
It just isn't. Well, you know, you're a really smart guy.
No, I'm not. Well, give me an easy problem.
You want an easy problem? Okay, I can't give you that one then. Actually, this is not easy, but this is a different type of problem. This is good, Josh. If you get this, Josh, now you will definitely pass the AP exam. Now, if you don't get it, doesn't mean you won't pass it, but if you get this, you're all set. Do you have any relatives? Our producer wants to know if you're any relatives in Waco.
Yeah, probably.
Probably.
Dead air. Okay, hello?
Yes.
So you take the derivative,
Okay, take the derivative. What's the derivative?
3x squared minus 10x plus 3,
Okay.
and no?
Yeah, no, that's right. Now what do we do?
You set it equal to,
Let me ask you something. If the function has a relative minimum, so if you, whatever a function looks like, if it has a relative minimum, what's happening when there's a relative minimum? What do we know about the derivative?
the derivative is going from negative to positive.
The derivative changes from negative to positive, but what is happening at the exact point?
It's 0.
Right, so we want to find when the derivative is 0,
Alright.
okay? So we got, oh man, how do we do this?
Quadratic.
Yeah, you can use quadratic formula, you can factor. Which one do you want to use?
Factor out, x. No.
Cannot factor out x. You want to use quadratic formula?
Sure.
Okay, so what's quadratic formula?
The opposite of b,
Which is what?
10 plus or minus square root of 100 minus 4 times 9, 36.
Mm-hmm.
So 10 plus or minus 6 over 6.
Okay, so what's the square root of 100 minus 36? What does that equal?
That's 6.
What?
Oh, 8, sorry.
So you got 10 plus or minus 8. So you got 18 over 6, and you got 2 over 6, right?
Right.
So you got either
3 1/3.
3 or 1/3. How do we know which one's the relative minimum or not? That's when the
when you plug it in and it's
what you could do, Josh, is this little chart right here.
right.
And if you plug in like a number like 5 into the derivative, you're going to get something pretty big, 75 minus 50. If you plug in the number 1, you get a negative. If you plug in a 0, you get a positive. So the function's increasing, decreasing, increasing. So which point, which one has which is the relative min?
X equals 3.
Okay, at x equals 3 is a relative minimum. So now let's see if we can answer the question. At x equals 3, we know the function has a relative minimum.
Right.
And we want 11 to be that relative minimum.
Okay. So plug in 3 for x.
Which one? 3 for x here, top or bottom?
The top.
Okay, we plug in 3 and we got 27 minus 45 is negative 18, plus 9 is negative 9 plus k. So f of 3 is equal to negative 9 plus k.
So you set that equal to 11.
Set that equal to 11 and you get k is equal to 20. So in other words, if k is 20, then this graph is a true statement. That if this is 11, the minimum we know is already at x equals 3. If we want the y value to be 11, then k would have to be 20, right?
Right.
You understand all that?
Yeah.
That's actually a pretty hard concept. So that's a good job there, Josh. It's good hearing from you.
All right.
Bye. Bumika Kapadia.
Hi.
Who pronounces your name right every time?
You do.
Thank you very much. Bumika Kapadia. It's a great name. Hey, how are things going?
Good.
Where are you going to school next year?
UTD.
UTD, what are you going to major in?
Either pharmacy or some medical-related field.
I think I've already asked you this, haven't I?
Yes.
Did I ask you every time?
I think.
Because I already knew that. Okay.
That's okay, then.
Sometimes you change your mind, though. Hey, Bumika Kapadia,
Yes.
how about this problem?
Oh, Lord.
Oh, Lordy. Storage tank has a shape as shown.
Oh, I can't do volume, Mr.
Well, you're going to have to try.
Okay.
Okay, so you got y equals 1/9. This is 1/9 x squared. This is from x equals 0 to x equals 3. By the way, what point is this right here?
I have no idea.
Yes, you do. If x is 3, what would this point be?
3? Oh, wait, x is 3, then it's 3 squared, 9. What's that, 1 over what?
1/9.
So it's 1. Y is equal to 1.
Y is equal to 1, right? Okay,
Right.
that's not so hard, right? Okay, now we rotate this about the y-axis. Now, first of all, is this going to have a hole or no hole? First of all, before you do that, if it's rotated about the y-axis, are we going to go from 0 to 1 or 0 to 3? If it's rotated about the y-axis.
0 to 1.
0 to 1, right? So the first thing you're going to write down, you write down 0 to 1. You have a dy out here. Now, the point here is that if it's 0 to 1, is there going to be a hole or no hole?
No hole.
All right, because you're from 0 to 1, you're taking all of these puppies. Woof, woof. Right?
Right.
So therefore, then it's just a simple volume problem. If there's no hole, what's the formula every time, Bhumika Kapadia?
Pi r squared.
Pi r squared. Okay, now what is the r?
It's, let's see, the radius.
It's the radius, and what's the radius?
3.
The radius varies.
Oh, x.
The radius is x. Excellent. Now here's the only problem. When you rotate about the y-axis, use y points and you use dy, you have to have it in terms of y. Right?
Right.
So what is that?
You're going to take your x and put them into your y.
Huh?
I have to rearrange the equation.
Okay. We want to know what x squared is. If y is 1/9 x squared, real quickly, what's x squared?
9y.
Excellent. So that's all you do. It's 0 to 1 of 9y dy, and that's the answer.
Okay.
Wasn't that exciting,
Yes.
Bhumika? Say that was more fun than I've had on a Thursday afternoon in the last 3 days.
And Miss Arthur wants you to stop doing so many volumes.
She wants me to stop doing so many volumes.
Yes, because we haven't learned it. They haven't learned it.
That is very rude of me, isn't it?
Yes.
I understand. Ask is Miss Arthur taking care of the PSAT stuff for the school?
Yes.
Thank you very much, Mrs. Arthur.
And Casey wants to know if you got her logistics and...
I know, I thought about that about half an hour ago. I did promise her I'd get that for her, and I do not have it. So,
Thank you.
no, thank you, Bhumika Kapadia.
Okay.
Is this Laura Jefferson?
Yes, it is.
How you doing?
Good, how are you?
Hey, did you enjoy the English thing Saturday? You can tell me the truth now.
Oh, yeah, that was just a blast.
Really, what was your favorite session?
I don't know. 18th century poetry.
I think it's 17th century.
Oh, whatever.
17th with Dr. Rice?
No, I didn't go to that one. Hey, why weren't you at the softball game on Monday? Julie wants to know.
I have to work for a living.
Oh, whatever.
What is this here? Did you win?
Yeah, of course we did.
What was the score?
7-2.
Well, don't you have another game?
Yeah, next weekend, Saturday.
We
April 7th.
have a math prep session. You're skipping the softball game to go to the calculus session.
Okay, yeah, sure.
No, yeah, that's right.
Okay.
Yeah, I'm running out of problems here. Okay, here we go.
Can I have a BC problem?
A BC problem?
Yeah.
Okay.
Nothing hard, though. And Matt's here, and he wants to talk to you when I'm done.
Oh, he does? Okay. Well, I got to think of a BC problem off the top of my head here. Okay. Does this
Easy, not sequences.
that's the only thing I know how to do.
Oh, fine, I'll try.
Okay, well, here's a good problem here. Somebody asked me this the other day here. What is this?
Just say x goes to 0.
Write bigger, we can't see.
Write bigger, okay.
The limit. 0 on the right side. Lord, I have no idea.
BC problem, there you go. Can you see that?
Yeah? Okay, hold on. Okay, the integral of natural log is, you have to do UV, don't you?
Yeah, you do.
Okay,
This is for BC only, so if anybody's AB watching this, you can learn, but,
okay, your U is natural log of x.
okay,
Your dV is dx,
okay,
which makes your Vx, and your du 1 over x. So then you have uv, which is x natural log of x, minus the integral of v du, which is x over x dx, so it's just integral of dx.
what's the integral of dx?
X,
Right,
okay? And then,
okay, so that's the integral.
right,
So what do we do here? Now this is where it gets hard. That was actually the easy part.
right,
This is a really hard problem, Laura.
okay. Do you just go ahead and plug it in and stuff?
Plug it in. Go ahead, plug
Okay,
it in.
2 natural log 2x minus 2, and then minus b natural log b plus b
Minus b.
minus b.
But now it's for the limit.
No, but it's minus a negative. It's plus.
You're right. I
Thank
apologize.
you.
That's right. Well, it's 0, so that's why I wasn't concentrating. So now, how do you do this? For the limit as b, now limit as b goes to 0. What is, okay, this is obviously 0, right?
Right.
And this stays the same. So it's 2 natural log of 2 minus, what is, as limit as b goes to 0 from the right, what is b natural log of b?
No, 0?
Well, when you plug in 0, when you plug in 0 here, but what's the natural log of 0?
And at 1?
No, it's,
E?
the natural log of 0 is really, it's negative infinity, and let's show you why. So, and that, we still haven't got to the hard part. It's a really hard problem. Okay, so what we have is, we know the natural log of x is equal to the integral from 1 to x of 1 over t dt, which is the area, it's the area from underneath 1 over t from 1 to, like, the natural log of 2 is this area from 1 to 2.
Uh-huh.
Well, the natural log of 0, it doesn't close off here, so what it is, it's this area, if it's less than 1.
It never reaches 0.
Right, like the natural log of 0 is equal to the negative from 0 to 1 of 1 over t. So it's like negative, and this is like infinity. You sort of see that?
Right, yeah.
Okay, so if you have 0 times negative infinity in a limit, what do?
You have to take the derivative? No.
Well, you're close.
Well, because, like, that rule where you take the derivative. Oh, my gosh.
L'Hopital!
Yes, L'Hopital's rule.
There you go.
Don't you take the derivative?
But wait a minute, here's the problem. L'Hopital's rule, you can only use 0 over 0, infinity over infinity. This is 0 times infinity. What do we do if you have 0 times infinity?
I don't know.
You got to make it into a L'Hopital!
Oh, take to multiply it.
So now it's natural, if you rewrite b natural log of b to natural log of b over 1 over b.
Right.
If you do that, now you have infinity over infinity. Because now you can do L'Hopital! So this answer to this, now you take the derivative of the top and the derivative of the bottom, which is 1 over b over negative 1 over b squared, which just simplifies to negative b, and now when you plug 0 in, you just get 0.
Right.
So your instinct was right. The answer was 0, but you got lucky.
Okay.
So the answer is 2 natural log of 2.
Thanks, Mr. Pfeiffer.
No, thank you.
You want to talk to
And
Matt?
next Saturday, you're not pitching. You're going to be at the prep session.
Okay. Do you want to talk to Matt real fast? Here, hold on one second.
Real quick.
Hello?
Matt,
Yeah, they said you wanted to talk to me.
I thought, is Ashley Cloud there?
Yeah, I think so.
You put her on the line.
Here you go.
Hello.
Ashley, what are you doing April 21st? Matt wants to ask you the prom. This is a dating service, I tell you. So you guys got to hang up because if you say no, I'll be too embarrassed. So you better say yes. Call in again, all right? Congratulations.
Okay.
Bye.
Thank you. Bye.
Allison Hall.
Yes.
Did you sign up for that lit test?
Yeah.
Okay, all right. Did you get Kara too also, Miranda and everybody?
Not exactly.
And Miss Fusilier?
Hold on, Miranda, you taking the test? No, Miranda's not taking the test.
Is Miss Fusilier, okay, tell Miss Fusilier to take care of it for you, and that's good, that's great. Hey, Allison, how come you didn't come Saturday?
Because I just decided this week that I'm actually going to take the test.
Awesome, baby, awesome, all right. Hey, just for that, have you done volumes yet?
Yes, but I'm totally confused after the last problem, so don't hit me
Oh, the
too
last
hard.
problem was a BC problem.
Yeah, I know, but it's confused my brain anyway.
It scared me too, so it really did. Okay, let's do this problem here.
Okay.
We'll do an easier volume problem. We haven't done this one yet. It's the same type of region we've been doing.
Mm-hmm.
Y equals x squared, x equals 2, and rotate, and we're going to rotate about the line x equals -1. Okay? First of all, are we going to use 0 to 4 or 0 to 2? Which one?
0 to 4.
0 to 4 because it's like the y-axis, right?
Mm-hmm.
Okay? And is there going to be a hole or no hole?
There is a hole.
There is a hole, right?
Yes.
Okay? So therefore, if there's a hole, it's going to be r squared minus r squared, right?
Mm-hmm.
Okay? So therefore, what are you going to do from there?
We're going to have to get it in terms of y in terms of, x in terms of y.
Is it going to be dy or dx?
dy.
Okay. And what are we going to do from there?
Do that. So, find y in terms of x. X in terms of y. Whatever.
Okay. So what?
Square root of y equals x. Let's do that first.
Okay. So it's going to be. Tell me again one more time what you think it's going to be.
Well, you want to do the big R first?
Let's do the big R first.
Okay, the big radius is 3.
3 every time, right? Okay.
Mhm.
And what's the little radius?
It's going to be 3 minus, no, I'm sorry, negative 1 minus, square root of y squared.
Okay. Well, let's take a look at this. It's going to be, it's this part right here plus this part. What's this part going to be?
1.
It's going to be 1, right?
Mm-hmm.
And now, and this part is going to be x, so it's 1 plus x, which is square root of y. Do you see that?
Uh-huh.
And that's excellent. That's how you set it up, and then from there you can expand it out, but we're not going to do that. But do you see that? Do you understand why it's 1 plus square root of y?
Mm-hmm.
Hey, Allison, that's great. This is a really hard problem. Okay? It's a really hard problem. Hey, I think we got Allison. Good job. I think you're gone. Hey, who's Richard?
Yes.
Richard?
Yes.
Skyline?
Yes.
Last name?
Herrera.
Hey, how you doing?
I'm doing all right.
Okay, we got time for one. We have time for one problem here. I'm going to give you. Let's see how you are with derivatives here. This is probably too insulting for you, but why don't we go ahead and fly with this? All right.
Okay.
What's that? Is that Catherine Morgan?
Yes.
What'd she say?
She said she wanted to say hi.
Yeah, let me say hi.
Well, tell her I say hi also.
Let me say hi.
She wants to.
Hi, Mr. Placer.
Hi, Catherine.
I suppose you want to talk to him, huh?
Yeah.
Why?
Because we only have a minute left
Okay.
or so. Okay.
Okay, I'm back.
Okay, go ahead and do these 3 problems real quickly.
Okay, I guess you bring down 3, make it 3 times the natural log of x squared.
Okay, so we want to, well, actually, so you want to make this 3 natural log of x is like that?
Oh, no, wait. It's, what is it? 3 natural log of x.
What is it?
3 times the natural log of x. So 3 natural log of x.
You want to rewrite it to be 3 natural log of x. Now, when you take the derivative, what do you get?
3 times 1 over x. So,
Which is 3 times 1 over x, or just 3 over x?
Yes.
Well, you also could have done, it's the natural log of u, and the derivative of u is 3x squared all over x cubed, right?
yes.
So that is equal to 3 over x, right?
Uh-huh.
Okay, so therefore, y equals natural log of x quantity cubed, so what do you do from there?
Let's see, 3 times 1 over x squared.
So it's 3 times natural log of x squared times 1 over x, right? Okay, and what about y equals e to the sine of x?
So your u is sine of x, isn't it?
Yeah, it's okay. Good, Richard.
Okay, so your du would be cosine of x,
Good. Cosine of x times what?
e to the sine x.
E to the sine of x. Yay! Hey, Richard,
Yes.
let me ask you something. Are you going to go to the April 7th math prep session?
Actually, I have a physics competition that day.
Physics competition?
Yes.
Are you taking Physics C with Mr. Castro?
No, I'm taking physics B with Mr.
Mr.
Chavez.
That's excellent. That's excellent. You're going to take the Physics B exam?
Yes.
Oh, that's very good. Very good. Hey, listen, have a great weekend, and make sure you call next week. Don't forget, Richard, that we have every week the question of the week, a $10 prize to go to www.apstrategies.org. And this week's winner is from the great Skyline Raiders, Francisco Hernandez. Y'all have a great week. We'll see you next Thursday. Bye.
Bye.